In this video, we are going to study our next chapter, Nano Materials. Okay, so synthesis and fabrication of nanomaterials. There are two main processes used for the synthesis of nanomaterials. One is the top-down approach, is an example for ball milling process. Bottom-up approach, there is an example for CVD, chemical vapor deposition process. Okay, in top-down approach, the bulk materials are broken into nano-sized particles. In this approach, there is no control over size of the particle. Bottom-up approach, it refers to the building up of a material from the bottom, that is atom by atom. So molecule by molecule or cluster by cluster. Okay, top-down approach is a bulk to powder, powder to nano, nano to plus. Okay, and bottom up is a atoms to clusters, clusters to nanoparticles, like that. Okay, so top down approach, we are reducing the size into nano. Bottom up approach, we are combining all the atoms clusters to form a nano materials. Okay, so to nano scale range. Let us see what is the ball milling technique. It is one of the top down approach for the fabrication of nano materials, that is of particles. This is a very popular, simple, inexpensive and extremely scalable method to synthesize all classes of nanomaterials. It's a very easy method also. This method is used to produce nanocrystal or amorphous materials. So how the construction will be, let us see. So the ball mill is a cylindrical drum containing grinding balls inside the drum and is used in grinding materials. There is a lid container powder particles and the tungsten carbide balls, which is used to fine the powder, grind the materials. Okay, now the balls are made up of the dense materials like steel or tungsten carbide. Either refractory balls or steel balls or plastic balls are used depending on the materials to be synthesized. The hardness of the cylindrical drum and the balls must be higher than that of the material used for grinding, because even more stress is applied, then it will confine into a powder. Okay, so the hardness of the cylindrical drum and the balls must be higher than that of the material used for grinding. So high energy mills used for the fabrication of nanoparticles. Okay, see here what is happening. Okay, how the ball milling will be inside that container. Okay, and next, how it will work. The small balls are allowed to rotate inside a container and then it is made to fall on a solid base with high force to crush the solid into nanoparticles. When balls rotate at the particular RPM, that is the necessary energy is transferred to the powder from the grinding balls. So now the energy transfer depends on rotational speed of the balls, size of the balls, number of balls and milling time. So how much energy, that will depends upon all these terms. Next, cryogenic liquids are used to increase the brittleness of the powders and a harder material will be selected to synthesize the softer material. And alpha, that is the alumina and zirconia are used widely as balls for synthesizing the nanomaterials because of their high grinding resistance. Depending upon the resistance, we are using the grinding materials. Let us see what is the advantages, disadvantages and applications of top-down approach. There is a ball milling. This method is used to produce few milligrams to several kilograms of nanoparticles in a short period of time. This is the advantage really. And what is the disadvantage? The contamination of milling media and atmosphere and is restrictive for the production of nanometal oxide nanoparticles. So actually this is a disadvantage. and applications. This method is used to prepare wide range of elemental and oxide powders such as cobalt, chromium, like all those. Now this method is useful in producing new types of building materials, that is a fireproof materials, glass, ceramics, like that. So the method is used producing new types of building materials like all those, and varieties of intermetallic compounds of Ni and Al, nickel and aluminium, can be formed. Okay, and next, what is the chemical vapor deposition, which is the example for the bottom up approach. In this method, this is used to prepare nanoparticles of composites, metal oxides and metal carbides. Okay, now the Cvd apparatus consists of three chambers. One is the heating chamber, the second is reaction chamber, and the third is a cooling chamber. Okay, let us see what's happening inside those. Okay, there's a vapor, precursor, inductive or resistive heating. There's a heating and there's a heating reaction. Clusters, how the clusters will be. After condensation, how the particles will be collected. Let us see. The metal organic precursor is taken into the heating chamber and is heated to a high temperature by using inductive or resistive heating method. Then precursor can be melted and evaporated. Inert gas like helium, neon can be acts as carrier gas and carries the precursor vapor to the reaction chamber. Some other reactants are introduced into the reaction chamber. Now the precursor atoms may collide with the cold reactant atoms and undergo condensation through nucleation and form clusters. So the precursor, what's the action of precursor here? The precursor atoms may collide with the cold reactant atoms and they undergo condensation through nucleation and forms clusters known as nanoparticles. Now the other reactants added into the reaction chamber that can control the reaction rate and cluster size. So the cluster size is controlled by the rate of evaporization, rate of condensation and rate of cluster formation. The size must be controlled. Next, the clusters from the reaction chamber is passed into the cooling chamber and it contains rotating cylindrical device on a cold finger. A scraper is attached to the rotating device. Now liquid nitrogen is used for cooling the cooling chamber. The nanoparticles are allowed to condense on the rotating cylindrical device and the scraper is used to collect the nanoparticles. Okay, all the components is within the diagram only. Okay, now let us see what is the advantages. A wide range of ceramics including nitrates and carbides can be synthesized. More complex oxides such as barium titrate or composite structures can be formed, and in this technique single phase and two phase nanoparticles can be synthesized. Okay, so simply this is about